Right, so in mathematics, I'm sure, I don't know, are you one of those people that goes, but how does this help you in real life? I'm not one of those people, but are you one of those people? Well, you know why I'm asking, because today, practical examples or practical uses. So let's go into it, right? So we're gonna go through two examples, and the second one you're gonna think isn't that practical, but it's very, very quick. And the first one is a little bit in depth, so let's go through it slowly. So we've got this tree. At the end of the first year after planting some sort of tree, it's 1 meter tall. In the second year, its height increases by 56 centimeters. And then in each successive year, its height increases by 7/8 of the previous year's increase in height. Okay, so what's going on here? Let's draw some pictures of our trees here. So we've got our tree. And to start with, I'm just going to draw it as a little stick. It's 1 meter. Then in the second year, it increases by 56. So it's like 1.5 times as tall, right? Great tree. And then, do you want some little branches or something? And then the next, the branches should really go that way. But anyway, here's our monkey tree. And then in each successive year, its height increases by 7/8 of the previous year's increase in height. Okay, so the first question we have is, in this third year, there's our tree getting nice and big. Determine the increase in height of the tree in the third year. So this is the first year. It grew to 1 meter. Let's go in centimeters. In the second year, it increased by 56. So it got to 156. But the increase was 56. And at the end of the third year, we asked, how much does it increase by? So, what are your thoughts? Oh, there's quite a lot going on. And maybe I got this. Or maybe you're thinking, sure, there's a lot to wade through here. It increases by 7/8 of the previous year's increase in height. So in this year, in year 2, it increased by 56 centimeters. So in year 3, it's just going to increase by 7/8 of that year, of 56, which gives us, well, that actually works out quite nicely, but you know what? Always nice to have our calculator ready to go. And our calculator says that 7/8 of 56 gives you 49, right? Because it goes in there 7 times. So 49. So in other words, that's the increase here. So this is the stuff that we need to keep track of, is to go, there's been an increase by that amount. The total height is this amount. And that's really what we need to keep our wits about us for. Okay, so determine the total height of the tree after 3 years. Okay, so how do you work this out? And what is it? Well, it was 100 centimeters after the first year, plus 56 it grew in the second year to give us 156, plus 49 it grew in the third year to give us some magical answer where we go 100 plus 56. Yo, this doesn't work that well. I must click with the mouse, I think. Plus 56 plus 49 equals 205. So, in other words, it's 205 centimeters altogether after the third year. Okay, now the fun can begin. And begin it does, because let's get rid of this calculator. Come on, go away, calculator, so we can see. Jake says that by the end of the 5th year, the tree will exceed a height of 3 meters. But Delphina disagrees with him and says that the tree will only exceed a height of 3 meters after 6 years. Is either of them correct fully justify your answer by means of some great mathematical calculations. Okay, so let's kind of work our way into this and say what we had up there was quite important. Started 100 centimeters. It grew by 56. It grew by 49. And each year it's growing by 7/8. So I'm purposely just giving you hopefully enough to go to get from there to there. We're timesing by a constant ratio of 7/8. That's what we're doing each time. Now, no, we can't just write the first few terms out. We need to use some nice formulae, and so the question could be after 10 years or something. So we don't want to go through that. So let's check this out. What do you notice then about this bit here? What is exciting about it? And I didn't know how to ask that question. I'm going to be like, what type of series? Because then we're already there. It's a geometric progression, right? And in this case, a geometric series because we're adding. So the 100's the 100 plus. That's going to happen at the beginning. And this part here is just a GP. So it's a geometric progression. And our geometric progression has a first term, has a constant ratio. And then we're going to see a number of terms in it to make sense of it. So what is the first term of our geometric progression? Well, it's 56. And the reason I separate that out as a question, just to make sure it's this part here. This is the GP, all of this stuff. Not the 100. That's just what we're adding at the end. Okay, what's our constant ratio? Well, our constant ratio is 7/8 because that's what we're multiplying by each time. And then for n, it's going to depend on who we're following. If we're following Jake or if we're following Delphina. So let's start with Jake. So Jake says that by the end of the 5th year, the tree will exceed a height of 3 meters. So we're going to go 100 plus. We know some formula for geometric series. We're like, oh, cool, that's a 1 minus r to the n over 1 minus r. I know you knew that, so I didn't have to ask you. And we're going to go here for Jake. And Jake's one is 100 plus a was 56. 1 minus r to, I think that's meant to be an 8 underneath, to the power of n. 1 minus r. And the question is, for Jake, so he's going what? At the end of the 5th year, what is our value of n? Okay. Maybe you put it down. I always say that, right? And I'm like, I really want to see what you thought. Now, the end of the 1st year was 100 meters. Then this was the end of the 3rd year. So if we're getting to the end of the 5th year, it's only 4 terms of our geometric progression. Look, 1, 2, 3, 4. So n in this case is 4. Okay, so Jake figures out that the height of this thing here, calculator to the rescue, is fraction 56, 1 minus 7/8 to the power of 4. And that's over 1 minus 7/8. I guess we could have written an 8th there, but you know what? 7/8. Okay, and I'm purposely just leaving that calculator bit up there. Let's really get it nice and big there. Just to point out these, the 7/8, we're raising that whole 7/8 to the power of 4. So that's why I just wanted to show you that bit there in our brackets, just to make sure. I think you are getting that right, but just to be doubly sure, right? Okay, so we press equals, and what do we get? 185,39. Okay, so that's what this part is. That's what the geometric progression was. So we still just needed to look at our calculator and say, okay, that was the GP, but that 100 in that first year as well, to give us 285,39. 285,39. So what did Jake say? Jake says that by the end of the 5th year, it'll exceed 3 meters. Sorry for you, Jake. You were wrong. Okay, what about Delphina? So Delphina's going to do a similar calculation. 100 plus 56, 1 minus 7/8 to the power. Now we've played this game already, so we know that's 6 years. We're going to have to put a 5 there. Over 1 minus 7/8 equals. Now what's cool about our calculator is that I haven't removed this stuff, so I can just change this here to a 5 and 318,22. 318,22. Right, so was Delphina right? Nope, sorry, Delphina. 318,22. Oh, well, my head's in the way. But Delphina, you weren't right because you said that the tree will only exceed 3 meters after 6 years. Well, after 6 years, straight on after 6 years, it gets 318. So it must have been in that 6th year that it exceeded that height. Okay, and then the last bit here is calculate the maximum height to which the tree will grow. Feels weird that the tree is going to stop growing. Let's just revisit. We said we've got 100 plus 56 plus 49 plus. So in other words, can we just keep adding this? That feels like a sum to infinity. When can we use sum to infinity? When can we use this 1 minus r? What am I doing? I haven't simplified it yet. When can we use a over 1 minus r for our sum to infinity? What do we need to know to use that formula? Well, we need to know that the ratio, this only works if the ratio is between minus 1 and 1. Our ratio is 7/8, so we're good to go. Plug in 56 over 1 minus 7/8. What do we still need to add to this so that we get the full height of the tree? 100, yeah. Wow. We're cruising, hey? So plus 100 equals 56 divided by 8. Well, my dear friend over here is going to help us and say 56 divided by 1/8 plus that 100 after the first year, 548. So if we really wanted that, we might say 5,48 meters, but everything's been in centimeters. So 548. Is that what we said? Yeah. Centimeters. Okay, that's that. Last quick one. 1,9 recurring equals 2. Show it. Do you ever say what moment like I put up there? Like, say what? And that say what might have been. What does this mean? So 1,9 recurring is like 1,99999. And if we keep doing that forever, this apparently is equal to 2. Now, it's funny that we kind of looked at this in class the other day, just a few of us. Some people that got the tree question. No. So 1,9 recurring equals 2. Do you have an idea at this stage of, or so don't say no, or I don't have an idea. Push yourself to think, what do you think we're going to use? I mean, we're in sequences and series. What do you think we could use? Really just pause, push yourself, and then I'll take us home for how to do it. But like, push yourself and put something down. Well, we're going to use sequences and series of some kind. We've got this one, and we need to add a few things. Well, if we're going to add things, what this 9 here, so let's do this in colors. That one there is 0.9. Then this one here is 0,009. And then this 9 here is 0,009. You see there's a bit of a pattern here that we're going to kind of keep going along with this forever and ever. So with a bit of luck, this whole thing here is some sort of geometric progression. How can we check if it is a geometric progression? We can see if there's a constant ratio. We know A is 0.9. And let's just check. R is, if we take 0,09 divided by 0,9. A tenth? Yeah, I mean, that makes sense. Those are like tenths, hundredths, thousandths. So our constant ratio here is 1/10. So our sum to infinity here is, we must add that 1, and then we must go a over 1 minus r. A over 1 minus r equals, what do you get? If you punch that into the calculator, do you get 2? Well, I'm punching into the calculator. In fact, I can see that 1 minus that is 9 tenths. 9 tenths of 9 tenths is 1 plus 1 is 2. Nice little mathematical proof of that. Okay, rock on with some exercises. I don't know why I put them so tiny there. Exercise 9, question 5, 6, 7. At least one of those is a bouncing ball because it's a classic question. As always, enjoy.